Hi, welcome to Sets of Real Numbers. So we're going to go through sets of real numbers. I don't want you to put a ton of focus into this one. It's important to know what the real numbers are, and we'll get to using the real numbers. That's really the more important part, is that you know how to convert that fraction to a decimal. You know how to get the square root, so we're going to get that. So let's start with sets of real numbers. You guys have seen this. You guys have seen this box here. Whoops, that's a terrible box. You guys have seen this box here before in 7th grade. We talked about rational numbers, and rational numbers can be written as a fraction. Anything that can be written as A over B, where B is not 0. If B is 0, you can't do that. It's undefined. You just can't, it's not possible. You cannot divide by 0. So rational numbers, and we know that rational numbers also include integers and also include whole numbers. Let's go to the next slide. So whole numbers, we call them counting numbers. These here are called counting numbers, 1, 2, 3. 0, when it added together, makes these all whole numbers. So they go on forever as far as you can count. Integers include all these whole numbers, but they also include their opposites. So not only do they include 1, 2, 3, they also include -1, -2, -3, and so on, so on, so on, so on forever. So rational numbers, anything that can be written as a fraction, where I can have something like A over B. Hold on, sorry. Where I can write A over B, and remember B can not equal 0. If B is 0, then you've got an undefined problem. So irrational numbers are anything that can be, it is one of those where it can't be made as a fraction. We've got a couple that we know of, and they are pi, which we know equals 3.14159, and it just goes on forever. If you really want to impress your fellow mathletes, memorize pi out to a stupid amount of digits and press them. E is also in there, but we don't really play with E. E comes a long time from now. Just remember, it's one of those. You'll probably never see it again. And the other thing is non-perfect squares. A perfect square is one where it comes out to the square root is a whole number. The square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3, because 3 times 3 is 9. Now, the numbers between the square root of 2 and the square root of 4, like the square root of 5, is non-perfect, which means it's irrational. And then all these are called real numbers. Whole numbers, integers, rationals, and irrationals, they're all real numbers. There's another guy, but you won't play with him until Algebra 2, and we'll just leave him alone out where he's hanging. So real numbers, we said irrational numbers cannot be written as fractions. So you cannot write it as A over B. It just doesn't work. That's a terrible B. It's non-repeating, which means it doesn't just go on forever and ever. It's non-terminating. It doesn't end. And here's some of our examples. We talked about these. All right, so let's put this to the test here and do some fractions and kind of get an ideal and get back into our thing. So when you're thinking fraction, remember it's 5 divided by 11. You got to say it in that word. So it's 5 divided by 11. Now, I know I'm going to need some zeros because I'm playing with, I know I'm going to end up with decimals. So here I go. 11 does not go into 5. I'll put a 0 out here. 11 does go into 50. It goes into it 4 times. And that leaves me a remainder of, I keep doing that, of 6. So I'll put my 4 up here. Remember to bring that decimal up. I'll get this right at some point. So when 50 minus 44, that gives me 6. I bring that down and I get 60. Well, does 11 go into 60? Yeah, it goes into it 5 times. That's 5 times. So when I do that, that's 5. And I bring down this 0. Now notice this 50 is the same as this 50, which means the whole process is going to repeat again. It's going to repeat for 4 and 5. So it's going to be 0.45454545, on and on. So I can indicate that in writing this way. It's a little harder on the computer. There's a couple of ways to do it. 0.4545 ... usually is the easiest way to do it. It indicates that it's a repeating point. So let's go to 1/8. So 1, remember we're saying it by this, divided by 8. I give myself some zeros. I usually give myself 3 decimal places because it seems to work out well for me. So does 8 go into 1? No. Does 8 go into 10? Yes. It goes in there 1 time. And that comes out with 2. Does 8, I'm going to bring this 0 down. Does 8 go into 20? Yes, it goes into there 2 times, because 2 times 8 is 16. And that equals 4. I'll bring down this 0. Does 8 go into 40? Yes, I love my 5s. 8 goes into 45 times. And that gives 0. So this one is a repeating decimal, right? This one's repeating. And this one's terminating. And that's from 7th grade, so we just remember that. Now let's do the last one, 1/3. 1 divided by 3. And hopefully you've learned this one enough on the door that, because it's one of the common ones, so you should know the answer without even having to do the work. But I'll do the work. 3 does not go into 1. We'll bring up the 0, put our decimal here. 3 does go into 10 9 times. Or, sorry, 3 does go into 10 3 times, because 3 times 3 is 9. And that comes out 1. Bring down that. Now, you'll notice again, this is the same as this. So we repeat whatever came before, and that's the 3. So we got 0.3 repeating. All right, let's answer a couple of questions on what they are. So we're going to write all the names, and it says all the names. That's important. Pay attention to the questions. All the names apply. So this baseball pitcher pitches 12 2/3 innings. That is a fraction. It's not a whole number because there's a fraction. It's not an integer because there's a fraction. It's a rational number because it can be written as a fraction or a ratio. Rational. Oops. And it's real because all the numbers we're dealing with are also real. Anything they ask for is also going to be real. So this one says the length of the side of a square that has an area of 10 square yards. All right, we're going to get into this into the next unit, but anytime you see a square with square units of measurement, in this case yards, it's a square root question. It really is. So the square root of 10, because we know that to get a square, it's length times width, but both of them are the same. So it'd be like length times length, which is a number squared. So 10, we know that 4 is a perfect square. The square root of 4 is 2, and the square root of 9 is 3. Well, this is the square root of 10. The next perfect one is square root of 16. So this is between the square root of 9 and the square root of 16, which means it's not a perfect square, which means it's going to be irrational. And remember, anything we're dealing with is also real. Watch out for questions that ask for all the names that apply and the ones that say, what's the best name that applies? Because the best just assumes the lowest level you can get. All right, I hope that's helpful. Go over this as many times as you need to. Ask for help, please. Have a great day. If I can figure out how to turn this off.